Alright, good evening. Today we're going to deal with a topic called prime factorization. Okay. Oftentimes where you will see this come up is when you're working with square roots, which you must simplify. For example, the square root of 8. Now, how do you go about solving this problem? First thing you want to do, step 1, is make what's called a factor tree. Make a factor tree. Alright. What do I mean by factor tree? Okay. Ask yourself, what are two factors of our given number that's under the square root? So, the number that's under my square root is 8. What are two factors of 8? What two numbers can I multiply together that will allow me to get 8? The answer, or one answer rather, is 4 and 2. Alright. Now, 2 is prime. The only number that divides evenly to itself is the number 1. So it's prime. However, 4 isn't. And remember, our goal is to find the primes, hence prime factorization. So, since we're done with 2, ask yourself now, what two numbers can you multiply together which will get you 4? The answer is obvious, 2 and 2. Ask myself, is 2 prime? Yes. Is 2 prime? Yes. Is 2 prime? Yes. So now, we're good. We factored all the way down to its prime. So we can rewrite our square root of 8 as the square root of 2 times 2 times 2. Okay, we're almost done. Alright, the next step is to circle any pairs we have. Any pairs of what? Numbers we have. Okay. So let's look back at our square root. We have 1, 2, 3 twos, so we have a pair of twos with 1 hanging over. Alright, now, why do we want to circle any pairs of numbers that we have? Well, the answer is simple. Because pairs makes squares. Pairs, plural, make squares. And that's important since we're dealing with square roots. Okay? Because we have a pair of twos, well, guess what? 2 times 2 gives us 4. So now, what's the square root of 4? Simply 2. So we take 2. That's the only thing that comes out because we're left with this 2 underneath our radical sign. We're going to write 2 square root of 2. And that's our answer. Okay? This works for any type of square root problem that you're trying to solve, no matter how big or small. Okay? Let's look at an example that my cousin sent me. The square root of 6,750 Pretty big number, all right? But just follow the steps. Steps 1 and 2. Step 1 says to make a factor tree. So, looking at our number, 6,750, we want to find out what two numbers we can multiply together that will equal 6,750. Now, off the top of my head, I choose 50 and 135. Don't worry, I didn't do this off the top of my head. I actually calculated it, but here was my hint. My number ends in 50, so I know I can count by 50s. And after 135 50s, we get 6,750. So now, again, we want to continue to find the prime numbers. So 50 isn't prime, but I know that I can take 25 times 2. That will give me 50. 2 is prime, 25 is not. 25 is actually 5 times 5. Those are prime. The only number that goes evenly into 5 and 5 is 1 in itself. Now 135 can be broken down. How do I know? For 1, it ends in 5. So I know at the least I can divide by 5. It gives me 5 and 27. 5 times 27 equals 135. Now 5 is prime again, but 27 isn't. Two factors which equal 27 are 9 and 3. And now finally, 3 is prime, but we have 9, and two factors which equal 9 are 3 and 3. And from the looks of it, it looks like I have all of my prime factors. So let me rewrite. Making sure I go in order. So I have 5 times 5 times 2 times 5 times 3 times 3 times this last 3. Okay? If I multiply 5 times 5 times 2 times 5 times 3 times 3 times 3, if I multiply all of those numbers, I should get 6,750. If I don't, then we know that we missed a factor somewhere. Alright, but it looks like we're all good. In fact, I know we're all good. So now, step 2. We want to circle any pairs of numbers that we have. Why? Because pairs make squares. So I have a pair of 5s here. Okay, this leaves me with a 2, 5. But look, I have a pair of 3s here. This leaves me with 1, 3. So now let's look at what we have. 5 times 5 equals 25. 3 times 3 equals 9. So, what's the square root of 25? Right, 5. And the square root of 9? You got it, 3. What do you do with that? Well, we're going to multiply it with this 5 that's out. Alright, what about everything that we didn't circle? Well, it stays under the square root. So we have 2 times 5 times 3. Alright, and now we're on the home stretch. We're multiplying here, so 5 times 3 gives us 15. Square root. We're multiplying here, 2 times 5 gives me 10. 10 times 3 gives me 30. And voila! That is our answer. The square root of 6750 can be simplified to 15 square root 30. Okay? I want to show you one more quick thing. Does this work when you have variables? Well, let's see. For example, if I take 3m to the 6th and n to the 4th, and I try to break down 3, well, 3 is prime, so no need to worry right there. But what about this m to the 6th power and n to the 4th power? Well, follow the steps. Make a factor tree, and then we're going to circle any pairs of numbers or variables that we have. Alright? For example, m to the 6th rather can be rewritten as m times m times m times m times m, one more, times m, 6 m's. And n to the 4th can be rewritten as n times n times n times n. Alright, so let's rewrite. What we have under the square root, 3 times m times m times m times m times m times m, 6 m's, m and m and m and m and m and m, alright, times n times n times n times n, alright. It's a pretty long expression. I agree. However, it's necessary because now that we've expanded it, we can see that we have a pair of m's here, a pair of m's here, a pair of m's here, a pair of n's here, and a pair of n's here. So, by us having one pair of m's, that gives us m squared. This is another m squared. This is another m squared. This is an n squared. And this is an n squared. Well, we're going to do the same thing we did before. Okay? The square root of m squared is simply m. The square root of this m squared is simply m. The square root of this m squared is simply m. The square root of this n squared is simply n. And the square root of this n squared is simply n. Okay? We didn't circle 3, so the 3 stays under the square root. And so now, we're going to multiply, and we're on the home stretch. How many m's do we have? 1, 2, 3. So that's m to the 3rd, n. So that's n squared, since we have 2 of those, square root 3. And that is our answer. Thank you, and I hope this was helpful.